This is the CSA 4 Study Guide Part 2. Number 6 says trapezoid EFGH is the image of trapezoid ABCD after a sequence of translations. It says select the true statements. Choose all that apply, meaning you're going to choose more than one correct answer. So, first thing I want to mention is EFGH and ABCD. I would like for you to write them EFGH, ABCD in that order, because as I've talked about, that order is very, very, very important. That order basically tells you how that trapezoid is changing, but certain things about that trapezoid are going to stay the same. Meaning the angles, E and A match, F and B match, G becomes C, and H becomes D. So, when we see these true statements, and we're trying to decide which one is true, AB, this symbol means congruent to EF. Well, A and B is going to be congruent to EF. That is true. AD is congruent to FG. AD is congruent to FG. That's not a true statement. AD is going to be congruent to EH. And if you look at the image, AD is here and FG is here, so that is not true. Angle D and angle H match. I just stated that earlier. That is true. That means they're congruent. They're the same measurements. Angle C and G are congruent. That is true. And then this symbol right here means parallel. So we're saying A and D is parallel to B and C. So look at the image. Is AD parallel to BC? Yes, those are two parallel lines. And then the next part says EH, right here, is parallel to FG. That is also true. So E is the final true statement. Moving on to number 7. Number 7 says figure DEFG is graphed on the coordinate axis. The figure is rotated 180 degrees clockwise about the origin to give you figure DEFG prime. Those apostrophes are called prime. Which statement about the sides of the figure DEFG after the transformation is true? So they're just asking us which lines are parallel. So typically for a rotation problem, I would get out the tracing paper and say, okay, let's rotate it. But for this problem, you actually don't have to do any of that, because if something starts out parallel in this image, it's going to end parallel. So we just need to figure out what two lines are parallel in the beginning. And the answer is DE and GF. So if we have the letters DEFG, and it's going to become DEFG prime, and if DE is parallel to FG, then DE prime is parallel to FG prime. So let's go through the list. DE is parallel to EF. That is not true. DG, right here, says it's parallel to EF. That is not true. GF is parallel to DE. That one is true. And then GF is parallel to DG. That is not true. So really, you don't have to rotate this problem at all. You just have to check and make sure that they are parallel to begin with before you start. And if they're parallel at the beginning, they're going to be parallel at the end. Just like your angles don't change, your measurements don't change when you're rotating something, your parallel lines don't change either. Number 8. Rectangle EFGH is the image of rectangle ABCD. So I'm going to go ahead and write EFGH and ABCD. After a sequence of transformations, that means that there's going to be more than one. So, just looking at what we're given, before we even look at the answer choices, I see A is here, and A and E should match. They're the same coordinate. So if A is going to come down here for E, the only way to get there is a rotation. Same with D. If D is right here, and according to this, D becomes H, it's got to rotate around to get to H. And also the second thing I notice is that the image gets smaller. The only transformation that makes a shape bigger or smaller is a dilation. So in that case, this has to be a dilation. So I'm looking for a dilation because it changes the size and shape. And then I'm looking for a rotation because it's got to rotate around to make that new image. So looking at my answer choices, it says, which sequence of transformations shows that rectangles are similar? Well, I see a dilation, 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 and a dilation. Okay? So it can't cancel out anything based on the word dilation. But I also see a translation. I don't see a rotation in this statement. I see a rotation here, so this is a possibility. This is a reflection, and I don't see the word rotation. And then this is a translation. I don't see the word rotation again. I'm looking for a rotation because if you have your tracing paper, and I trace this, and I'm just focusing on A and D, and you can do the whole image if you'd like, but if I rotate it around, it's going to end up in that similar spot. So the first thing we do is we're going to have to rotate, and then we have to dilate. So B's answer fits. Let's double check it one more time. It says a rotation 180 degrees counterclockwise about the origin, followed by a dilation with a center of 0, 0 and a scale factor of 3/4. So let's talk about scale factor real quick. Scale factor of 3/4 means it's going to get smaller. And if you look at your image, it absolutely gets smaller. If you have a scale factor of 2, 3, or 4, it's going to get bigger. But in this case, it does get smaller, so I'm pretty confident that B is the correct answer for that one. Number 9. Triangle DEF is the image of triangle ABC after a sequence of transformations. So again, we have the word sequence of transformations. It says, describe a sequence of transformations that proves the triangles are congruent. Well, first of all, if the triangles are congruent, you have 3 options. You have a rotation, reflection, or a translation. All 3 of these things will remain congruent. If you dilate something, it's going to stay the same shape, but it's going to get bigger or smaller, so dilations is out. You absolutely do not want to mention dilations in this problem because it is saying congruent. So, let's look at the image. I see it's going to be DEF is what it becomes, but it starts as A, B, C. So A is going to match up to D. So again, kind of like the last problem, there's no way for A to become over here unless a rotation happens. Typically, when you rotate something, it's going to change the orientation of it, meaning it's going to turn. And this is how the tracing paper works. So if I reflect, let's kind of rule out reflection. If I reflect here and I move it down, that does not match. Okay, start back from the beginning. If I reflect it over the x-axis and I move it over, it still will not match up. The only way this is going to match up is if we do some sort of rotation. So you may think, okay, rotate 90 degrees and then 180 degrees. Well, that doesn't get us in the right spot because it's not turned the right way. So we somehow need to get it to look like this. So there's actually two options here, two correct answers. The first correct answer could be this. You start here, and if I'm turning this direction, that is not going to be clockwise, that's counterclockwise. So I could go counterclockwise, one turn, there. And then I would translate over. So I'm going to stay there. It says describe a sequence of transformation that proves the triangles are congruent. Well, one sequence is you can rotate 90 degrees counterclockwise, then translate, and we have to figure out how far we're translating. So I'm going to leave it there. It's lined up. I would go over 1, 2, 3, 4, 5, 6. Okay, you can do that with each coordinate. A is going to move over 1, 2, 3, 4, 5, 6. B, same thing. You're going to move over 6 to get to E. So we're going to translate to the right. 6 units. And that's all you need for your statement. You don't have to prove that it's congruent because by saying rotate and translate, you know your image is going to be congruent. The other option is if you go back and you start there again, you can actually rotate 90, 180, and 270 degrees clockwise. So if you go this direction, clockwise, it would take 270 turns to get to the right spot before you translate over. So instead of saying 90 degrees counterclockwise, you would just change it to 270 degrees clockwise, and then everything else stays the same, and both of those answers are equally correct. Part B. Part B says, suppose triangle ABC is dilated with a center of 0, 0 and a scale factor of 1/2, and the resulting image is reflected in the x-axis to make triangle GHI. So again, we're changing the letters. ABC becomes GHI. What are the coordinates of point G? Well, what does G start out as? It starts out as A. So let's go back up to the top. My coordinate for A, right here, is -5, 4. See that? -5, 4. So I'm going to go down to the bottom, and I'm going to write that -5, 4. And we have a scale factor of 1/2. Well, what do we do with a scale factor? All you have to do is multiply. So think to yourself, what is a -5 times 1/2? That's going to give you -2.5, and 2 times 1/2 is going to give you 2. Remember, when you multiply by 1/2, you're just splitting the number in half, basically dividing by 2. So this is after the dilation, And we have one more step, and that's to reflect it across the x-axis. So, go back up, pay attention to this coordinate, -2, comma, +2. I'm going to graph that, -2, comma, -2.5, comma, +2 right here. And they say we're reflecting it across the x-axis. So this is your x-axis, and you're reflecting it across from it, so it's 1, 2 units away, and it's going to remain 1, 2 units away. This would be the new coordinate for G, and that coordinate is still -2.5, but instead of +2, it's going to be -2. So we're going to write -2.5, comma, -2. -2.5, comma, -2. Remember, when you are dilating something, all you're doing is multiplying.